Hello NET aspirants. Welcome to CSIR NET Thermodynamic and Statistical Physics series. Question number 1. There are two boxes, one at the ground level and other at the fixed height edge. There are three balls of different colors, each having mass m and radius r much smaller than h. There is no restriction on the number of balls that can be simultaneously put in a given box. For a given value of total energy E in the units of mgh, g being the acceleration due to gravity, the number of accessible microstates is omega e. The plot of omega e versus E will be. So here energy can be, since there are three particles, energy can be 0, 1, 2, 3, that's all. So E is equal to 0 means all the particles are at ground level. That means three particles are at ground level. That means this is way of choosing 0 particles from 3 particles. So this is 3C0, which is 1. If you consider E is equal to 1, that means exactly one particle will be at height h and two particles will be here. So this is 3C1, which is equal to 3. For energy equal to 2 units, exactly two balls will be at height h and one will be at 0. So this is 3C2, which is 3. And E is equal to 3 means 3 particles at height h and 0 at a lower energy. So all particles are at h. So this is 3C3, which is 1. That means omega 0 is 1, omega 1 is 3, omega 2 is 3, and omega 3 is 1. That means here option 3 is correct. 1331. Next question. The internal energy of the system is given by U, where V is the volume, S is the entropy, N is the number of molecules, R is a constant. The function g of n is proportional to. Now we know U is an extensive property, so U is proportional to n. Also V is proportional to n, and entropy is also proportional to n. So here I can write U is proportional to n, proportional to g n. V is proportional to n, so n raised to minus 2 by 3. Some constants will be there, but we will not consider that. And then we have in the exponential part. Anyway, exponential part will be dimensionless. So you can see here S is proportional to n and upon n, so it is constant part only. So from here, we can see that g of n is proportional to n raised to 2 by 3 plus 1, which is 5 by 3. So option 1 is correct. Next question. Consider 1 mole of an ideal diatomic gas molecule at temperature T such that kBT is much greater than h nu, when nu is the frequency of its vibrational mode. If Cp and Cv are specific heats of this gas at constant pressure and volume respectively, then the ratio gamma is equal to Cp by Cv is. Now we know translational degrees of freedom, that will be 3. This is a diatomic molecule, so rotational degrees of freedom equal to 2. Temperature is high, that means there will be vibrational degrees of freedom, so 2. So total number of degrees of freedom is 7, and Cv is equal to F into R by 2 for 1 mole of gas. So this will be 7R by 2, and Cp is Cv plus R by Mayer's relation, so this will be 9R by 2, and gamma is Cp by Cv, which is 9 by 7. So option 4 is correct. Next question. A refrigerator can be thought to be a reversible engine operating between T2 and T1. The work needed to run this is supplied by another engine that takes in energy at the rate of 500 watt and runs with 50% efficiency. The refrigerator freezes 5 kg of water at 0 degree Celsius, latent heat is QL for ice, in n hours, then n is closest to. Now what will be the work done? Now we know efficiency is equal to work done upon heat input. So work done will be eta into Q, and here eta is given 50%, that is 0.5, into input is 500 watt. So this is 250 watt. Now let's find out coefficient of performance for that refrigerator. So COP is equal to T1 by T2 minus T1. So T1 is minus 10 degrees Celsius, which is 263.15 Kelvin, and difference is 20 minus 10, which is 30. So now the energy that is given, that will be QT, and that will be equal to this coefficient of performance into work done. So this will be equal to 263.15 by 30 into 250, which is 2192.91 watt. Now energy required to melt that ice, that is equal to M into L, where mass is 5 kg and latent heat is 334 kilojoule per kg. So the time required will be this Q ice upon QT. So this is 5 into 334 kilojoule upon 2192.91 watt. Now this will be in seconds and we want in hours. So multiply by 1 by 3600. This will be in hours. And this comes out to be 0.2 hour. So option 4 is correct. Next question. Two discrete time random walkers start from the point x is equal to 0 at time t is equal to 0, taking discrete steps of unit length along the x-axis. The first walker is unbiased and the second walker is biased to move towards the right with probability p. The probability that they are at a distance of 2 units from each other at both time steps t is equal to 1 and t is equal to 2. So we want a probability that the distance should be 2 at both these times. So the total probability will be the probability that the distance at time t is equal to 1 is 2. This is a conditional probability. So at t is equal to 1 it should be 2 and at t is equal to 2 also it should be 2. So both events. So distance at t is equal to 2 should be 2. Condition that distance at t is equal to 1 is also 2. So we want to find out this. We'll focus on one part first. So for the first walker, x1. x1 can be plus or minus 1 with probability half because it is unbiased. And for the second walker, let's consider it y. So for him, y1 will be plus 1 with probability p on the right side, and it will be minus 1 with probability 1 minus p. The condition is distance should be x1 minus y1, this should be equal to 2. When is this possible? It is starting from 0. That means if x1 is 1, then y1 has to be minus 1. Then the distance will be 2. And if x1 is minus 1, that means y1 has to be 1. Then the difference will be 2. So only these two cases are possible. So the probability that distance at t is equal to 1 is 2 is equal to probability that we have x1 equal to 1 into probability that y1 is equal to minus 1 plus probability of x1 is equal to minus 1 into probability that y1 is equal to 1. That will be equal to simply half into 1 minus p plus half into p, which is half. So this is done. Now let's start with the second one. So we have x1 is equal to 1 and y1 is equal to minus 1, suppose. Then what will be values of x2? If x2 is 2, then y1 can be 0, then the difference is 2. No, it is minus 1, right? Yeah, so if it is minus 1, then it can be plus 1 will be 0. So difference will be 2. And if x2 is 2, then y can be minus 2. Then the difference will be 4. And if x2 is 0, then y can be again 0 or minus 2. Here difference is 0 and here difference is 2. So for these two cases, we'll get 2. And if we start with x1 is equal to minus 1 and y1 is equal to 1, then we have x is equal to 0 or x is equal to minus 2. Similarly, y will be 0 or 2. So here it is 0. Then we have 2, 2 and 4. So in this case, probability will be x2 for probability for x2 is half into we have 1 minus p plus half into p. So this will be 1. And here also, let's call it p2 dash. Here also we will have half into 1 minus p plus half into p. That is also 1 by 2. So this is the case. So in both the cases, you will get half only. So now the probability, total probability that I have written here. So we will substitute all the values here. So the probability that d1 is 2 into probability that d2 is 2 with condition that d1 is 2. So this will be equal to, it is half and then half. So half into half. So answer is 1 by 4. So here option 1 is correct. Next question. A rigid molecule can have two possible rotational states, J is equal to 0 or J is equal to 1. Its rotational energies are given by Ej, where I is the moment of inertia. For the ensemble of such molecules in thermal equilibrium at temperature T, the ratio of the number of molecules in the J is equal to 1 state N1 to those in J is equal to 0 state N0 is N1 by N0 is equal to 0.003. The temperature T in the units of h square by 2I kb, where kb is the Boltzmann constant, is closest to. Now what will be these energies? Here let's put J is equal to 0, then we have E0 is 0 and E1 will be 1 into 2. So h square by 2I into 2. And what will be the multiplicity of these energies? So Gj is equal to 2j plus 1. So G0 is 1 and G1 is 3. Now N1 by N0 is equal to 0.003 is given. This will be equal to G1 by G0, and in the exponential part we have minus of E1 minus E0 upon kBt. So I'll substitute all these values. So we have 0.003 is equal to 3, then exponential part minus, so this is 2, then h square upon 2I kb t. So t will be equal to, this will be 0.003 by 3, that is ln of it. So ln of 0.001, then we have minus sign here, minus 2 into h square upon 2I kb t. And this will be equal to 0.2895 h square by 2I kb t. So it can be rounded up to 0.29. So option 1 is correct. A thermodynamic system at temperature T and volume V is described by its internal energy U and pressure P, where A is a constant of appropriate dimension. The Helmholtz free energy of the system is F is equal to Helmholtz free energy is equal to U minus Ts. Now we have du is equal to Tds minus Pdv. So dou U by dou T at constant V is equal to T into dou S by dou T at constant V. We have expression for U. So differentiate it with respect to T. So it is 4a T cube V is equal to T into dou S by dou T at constant V. So dou S by dou T at constant V is equal to 4a T cube T, so T square V. So from here S will be equal to integrated with respect to T. So this will be T cube by 3. So 4 by 3 a T cube V. Some constant will be there, we can take it to be 0. So we'll substitute this in this equation. So F is equal to U is a T raised to 4 V minus T into S is 4 by 3 a T cube V. So this is 1 minus 4 by 3. So minus 1 by 3 a T raised to 4 V. So option 3 is correct. So these were all the questions from Thermodynamics and Statistical Physics part from CSIR NET July 2025 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.